Another characteristics of graphs are the relative minimum and maximum of a graph. So relative minima and maxima means that over a small interval section of the graph, you have a highest point or a lowest point. Okay, so highest point would be relative, lowest point would be, highest point would be a relative max, lowest point would be a relative minimum. Now, these are different from what we call absolute or global minimums and maximums. Okay, absolute or global means over the entire graph. Okay, so if it is the absolute highest point or the absolute lowest point of the graph, that's the absolute or global minimum or maximum. The relative, or sometimes you'll hear them referred to as local, are those that we find over this smaller area. Lots of times these are going to be our turning points. Every turning point is a relative minimum or maximum. So that's how you have to describe them. So here's an example of finding relative minimum or maximum points. Okay, so this graph has one of each. So let's look at that. So let's see, there is a relative minimum here. Why is that a relative minimum? It's a relative minimum because at that point, which happens to be -2, -1, is the lowest point on an interval around -2. Okay, this point is the lowest point on an interval around -2. Okay, now how do we describe that? That means at x equals -2, the function has a relative minimum value of -1. So here's what I like to say. Where is your x? What is your y? And why do I say that? It's because anytime we are describing where something happens on a graph, we're always going to be using the x value of the coordinate. Anytime we're discussing where something happens on a graph, we're describing that using the x coordinate. Anytime we're asked what a function value is, what is the function value? That is the y. So what is the function value? What is the minimum? What is the maximum value? Those are y coordinates. Where is the minimum? Where is the maximum? Where is the x? Okay, so let's look at the next one. Let's find the maximum. So let's describe this point. So that is a relative maximum. The reason that particular point, which happens to be 0, 1, it is the highest point on a small interval around x equals 0. That means at x equals 0, where's the x? The function has a relative maximum of 1. What is the y? So let's do another one. So let's identify where our points are. So we have a relative minimum here. We have a relative maximum here. Then we have another relative minimum here. So let's just start on the left with that first one. We have a relative minimum. Where is the relative minimum? Well, the relative minimum is at x equals -1. And it has a relative minimum value of x equals -2 because that point is -1, -2. So let's look at this other. Okay, so they've got the minimums together. So let's look at the other minimum. That point is 4, 0. So at x equals 4, there is a relative minimum value of 0. Then we have at x equals, so let's figure out what this point is. It is 2, 3. So at x equals 2, there is a relative maximum of the value 3. Again, where is x? What is y? So what about this one? Relative minimums and maximums. Well, it goes forever in both directions. So we're going up forever, we're going down forever. It doesn't have any turning points. So without an ending point or a turning point that can be a minimum or a maximum, we actually have none. This one actually has no minimums or maximum values. And it's possible for a graph not to have any.